You can solve equations of the form x squared equals k by finding the square roots of each side. For example, the solutions of x squared equals 81 are plus or minus the square root of 81, or plus or minus 9. Here's an example problem, number 2. Solving using square roots. What are the solutions of 3x squared minus 75 equals 0? What we should recognize about this equation that makes it a candidate for this type of solving is that we have a quadratic term, a constant, but no linear term. That allows us to, well, simply add 75 to both sides and continue to solve. Consider if we had let's change this just a bit, a 3x squared plus 2x minus 75 equals 0. Note the presence here of a linear term. This would not be such a good candidate to attempt to solve using this square root method. Back to the problem at hand. Our next step using SADMAP to undo the order of operations would be to divide both sides by 3. X squared equals 25. Now applying the square root to both sides, we would find, well, square root cancels with squared. And we have x equals, well, plus or minus the positive or negative square root of 25, of course being positive 5, but also negative 5. We should always check our solutions back into the original equation. Well, let's try negative 5 to begin with. Negative 5 squared is 25, 25 times 3 is 75, and 75 minus 75, a big 0. And the positive version, 5 squared, 25 again, and the rest is history. And one of 3 chances to show that you have got it. What are the solutions of the equation m squared minus 36 equals 0? Work carefully and make your selection from the choices below. Question 2 of 3. What are the solutions of the equation 3x squared plus 15 equals 0? Work carefully and make your selection from the choices below. And question 3 of 3. What are the solutions of the equation 4d squared plus 16 equals 16? Work carefully and make your selection from the choices below. You can solve some quadratic equations that model real-world problems by finding square roots. In many cases, the negative square root may not be a reasonable solution. Here's example problem 3. Choosing a reasonable solution. An aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism with a length L that is twice the width W. The volume of the tank is 420 cubic feet. What is the width of the tank to the nearest tenth of a foot? Well, we should first consider what we know about the volume of a rectangular prism. Well, volume equals length times width times height. Then we substitute in the values that we know. We know that the volume of the tank is 420 cubic feet, so we substitute that in place of V. We know that the length, written in terms of W, is 2W, right? We're told it's twice the width. Now W, we don't know the width, it will just stay the width. And then we are given the height of the tank in the image. Note it says 3 feet high, so 3 in place of H. I'd say at this point it's worth discussing. Why did we rewrite L as 2W? Now, what that does for us is it provides us with an equation with only one variable. Recall that's often our goal. If we have an equation with multiple variables, we'll have multiple solutions. Once we have an equation with only one variable, we'll have one solution. And our goal here is to find one solution. Had we left the equation as 420 equals LW times 3, well, you can see we'd have a much more difficult time solving it because we still have 2 variables. So being able to rewrite L as 2W, knowing the information that the length is twice the width, allows us to end up with an equation that only has W's involved, and then we can solve for W. Let's do that. Simplifying, we find 420 equals 6W squared. We would then divide both sides of the equation by 6 to find 70 equals w squared. Inverse operation of squared, taking the square root of both sides. Squared and square root, inverse operations canceling one another out. And we find that w equals the positive or negative square root of 70. Those are our algebraic solutions. Plus or minus 70 both make sense, well, algebraically. Remember, w represents width of an aquarium tank. So a negative width makes no sense. We measure distances in positive units. Therefore, our algebraic solution that we arrived at of negative square root of 70 doesn't work in this problem. It's not applicable. So we're just going to go with the positive version. Using a calculator, we find that the width is approximately 8.366. You can read that as well as I can. And don't forget, our units are feet, referring back to the diagram. So, a tank cannot have a negative width. Covered that. So only the positive square root makes sense. The tank will have a width of about 8.4 feet. And a got it question, or two got it questions. Suppose the tank in problem 3 will have a height of 4 feet and a volume of 500 cubic feet. What is the width of the tank to the nearest tenth of a foot? To help you out with part A, I've brought in a screenshot from problem 3. Take note that these are the dimensions from problem 3, not your problem at hand. Work carefully. And part B, a reasoning question. What are the disadvantages of using a graph to approximate the solution to problem 3? Explain. And your lesson check exercises for section 9.3.